Our planet was born in fire, then grew with disaster. Yet even then, the elements of life were present. Water was soon present on the surface. When calm, it would provide a sheltered cradle for the first life on Earth. While the planet was born in fire, it was baptized by ice. For millions of years, it was covered by a frozen shroud. Yet it seems that life not only persevered, but prospered. Microbes evolved into a myriad creatures, and one was the first to leave the oceans forever and tread on land. Only a few million years ago, creatures that we most resemble began to walk the earth. Our own lives seem so fragile, yet science tells us otherwise. It tells us that we are but a part of the greatest journey ever made. It tells us that all life is linked through time to those simple cells which drifted once in the first oceans of a miracle planet. "4.5 billion years ago, the Earth was a very different world. Under layers of thick gaseous clouds was a planet still hot from its birth, with an atmosphere both dense and crushing. Bathed in filtered red light were oceans far deeper than those of today. And there was one other great difference. The early planet was probably only a tenth of the size that it is today. But it was to grow. And that chance and violent growth would prove crucial to life's history and to what we are today. The early solar system was far more crowded than now. Where today the 4 inner planets orbit, 4.5 billion years ago were scores of smaller planets orbiting the sun. Orbits of some were drawn by gravitational force towards each other. Encounters of awesome magnitude were unavoidable. The force and heat of those collisions melted the rock, but gravity would hold the two together and then weld them into one. With each collision, the planet would grow larger. The lighter debris was cast off into space and then drawn into orbit around the enlarged planet. For some millions of years, the Earth had rings like the planet Saturn. It was chance and chance alone which made our planet larger than any of the other planets close to the sun. And somehow, somewhere in this chaos, life began. But quite where is open to conjecture and debate. Here in Greenland are some of the oldest exposed rocks ever to have been found. And one belt of rock, 4 kilometers, almost 2 miles long, may take us back as far as we can go in the long history of this planet's existence. Dr. Minnick Rosing of the Geological Museum of Copenhagen has visited Greenland many times in his research for evidence of Earth's early history. This is a layer of fossilized carbon which he believes might be the earliest evidence of life. Under the microscope, tiny black grains can be seen. These possibly are grains of carbon, the building blocks of life. If so, there may have been tiny microorganisms drifting in the water that were alive, taking in nutrients, reproducing, and then dying and dropping slowly to the ocean floor. When the carbon was deposited those billions of years ago, the thin straight lines on the rock show it was undisturbed, proof that this was the bottom of a deep ocean, and the thickness indicates that already life was plentiful.
This is not the emergence of life. It cannot be, because we have all this black color, and that means that there was very efficient life that could make a lot of carbon, and this life must have been very sophisticated. So life must have been had a long prehistory, and one could speculate that probably life formed on Earth maybe 4.3 billion years ago. When the oceans formed and the conditions for life were present, life could have emerged at that time. And definitely by 3.8 billion years ago, life had reached the level of sophistication that allowed it to live in the water and produce a lot of carbon. So it was highly advanced life at this time.
For these microorganisms, the prerogative was simply to survive. But the challenges to life were daunting. The early solar system was still a violent place. A massive asteroid from outer space heads straight for Earth. It's as large as the one that Moments after the impact, rock vapor, the temperature of the sun, begins to engulf the world. Could any life at all survive this impact? Immediately after the impact, the rock vapor rises up from the crater in a dome, then spreads out in all directions across the globe. 3 hours after the impact south of Japan, the expanding wall of vaporized rock reaches the mountains of the Himalayas. The ocean would start to bubble and boil, and as the water evaporates, the oceans would drop at the rate of 5 centimeters or 2 inches every second. Even the salt deposited on the ocean floor vaporizes, and then the very bottom of the sea melts. Nothing is left untouched. One month after the impact, the surface of the world has been sterilized. Now science is not so certain. Now there is the strong likelihood that life, despite the odds, has survived. But how could that be possible? With the oceans gone, where could life have found a sanctuary from the searing heat? A clue to the answer was found in salt. These salt lakes in the American Southwest are the remnants of an ancient sea. Millions of years ago, in the Permian era, the upheaval of the bedrock drained the oceans and left behind these lakes. Dr. Russell Vreeland is a microbiologist based at Westchester University. He's been studying the survival strategies of microbes and has come up with some remarkable results. To him, these crystals are as valuable as any gemstone. Inside the crystal are minute droplets of the seawater trapped within as the salt crystallized. A tiny hole was drilled so that the drop of water could be released. Perfectly shaped microorganisms named Bacillus permians were found, relics from the past. But the next finding was truly extraordinary. For 4 months, the microbes were fed with a nutrient broth. They began to divide, then multiply vigorously.
After slumbering through tens of millions of years, they had come awake. Dr. Sleep of Stanford University looked long and hard at early life's survival capabilities. He thinks that he's found an answer. There was a part of the Earth where life could sustain itself, and this was deep below the ocean floor. This graph shows the temperature distribution in the subsurface of the Earth. The red area is the heat from the Earth's core. Nothing can survive in this region. Green are regions below boiling point. Blue are regions just below 50 degrees Celsius or 122 Fahrenheit. Life could survive in the blue zone, the Goldilocks zone, as Dr. Sleep calls it. However, early life needed water, and the water on the surface of the planet was gone. Was it possible to sustain any sort of life in the rocks deep below the Earth's surface? Here in South Africa, that question has been answered. This is one of the deepest man-made shafts in the world. It drops down over 2 miles below the surface. And it's not just the miners who take the long trip below.
The geology, luckily, there's a lot of drop from the sky.
Dr. Esther van Heerden of South Africa's Free State University is researching the survival of life deep within the Earth. Her findings and those of the research team are astounding. Groundwater is seeping from the rocks, and the surface of the mine wall is covered by a thick film of white and black. This is a mat of various forms of bacteria, species not found on the Earth's surface. Here they do not use oxygen. They are anaerobic. But research shows that many of them still possess the genes for oxygen respiration, useless down here. Perhaps this is evidence that these microorganisms once lived on the surface, only to migrate to these depths, perhaps to escape the heat of a total evaporation impact. To survive is life's objective, and sometime after the total evaporation event, life must have once again returned to the surface. Immediately after the impact, the planet would have looked like a fireball. But within only a year, the rock vapor would start to dissipate and temperatures would begin to drop. Because of the Earth's size and gravity, the evaporated water would not escape into space, and within only 1,000 years, the water vapor would cool and condense, and then fall back as torrential rain. Once again, the oceans would start to fill. Rainfall would be as heavy as tropical rain is today, and in only 3,000 years, the oceans would have regained their original depth. The stage was set for life to return from the deep. Life on this planet had endured against all odds, from minute cracks and fissures in the bedrock. The underground life returned to the surface. Perhaps one day in the far distant future, life may once again be forced to revisit those depths. How many times this has happened, we perhaps will never know. For the next 2 billion years, life remained in the oceans of the world. drifting in the waters, taking nutrients, reproducing, and dying and living. The next challenge to life came almost 2 billion years ago. And if science is correct, it came not with a mighty impact, but slowly and insidiously. For millions of years at a time, the planet was shrouded with a thick covering of ice. Life endured that too, but how? It was called the Snowball Earth, and like many scientific theories, this one is hotly debated. Working with scientists at the University of Tokyo, a computer simulation was carried out to show what would happen to today's world if a snowball Earth event were to occur. At 35 degrees north, Tokyo is just a little further south than New York. Ice up to 1,000 meters or 3,000 feet thick would bury the city. At first, any life that could not find shelter would freeze to death. At the start, the glaciers would move slowly. It would take millions of years for the ice to reach a latitude where Hawaii and Cuba are. But from there to the equator would take only a few decades. Scientists believe that if there were snowball events then, they must have persisted for millions of years. During that time, the face of the planet would have seemed a frozen and desolate wasteland, as parts of Iceland are today. There was perhaps a chance that life could survive in water beyond the oceans, living from the heat and energy that comes from the Earth itself. Iceland is known for its volcanic and thermal activity. The land has only a thin crust above the heated mantle of the planet. It sits very close to awesome power and force. Hot springs are found across the island where the heat of the Earth forces its way out. Places like these could have been a safe haven for microorganisms which like the heat, the thermophiles. And it's places like this where thermophiles can live. Where the water bubbles out, it's too hot for just about any living organism. But cooler edges are full of bacterial life. The life in these pools is made up mainly of bacteria which photosynthesize. The microbes cluster together to form thick mats. The earliest evidence of organisms like this appear before the first snowball event. The mystery yet to be solved was how the ice melted. Once a planet like the Earth was frozen, it would reflect sunlight back into space and so remain frozen.
It occurred to me that a frozen surface would not influence the working of geology. And it just hit me one morning that, oh, of course, the carbon dioxide from volcanoes would continue to build up in the air.
It was the Earth's own forces which brought the snowballs to an abrupt and dramatic finish. One study has suggested that when the surface of the sea reaches 45 degrees Celsius, about 110 Fahrenheit, it would trigger weather patterns that the world has never seen before or since. temperature differentials would cause massive hurricanes to build. These hyper-hurricanes would generate waves the height of buildings. All this activity boosts oxygen production. After the first snowball event, there was little change in life. After the second, oxygen levels soared, and the first complex life appeared, expanding horizons and leading to higher and yet more complex life. These strange creatures which evolved from the snowball events would not last long, just a few tens of millions of years, before a new life force took over. Now, life could never step backwards, and it was in shallow seas around a vanished continent where the next step would be taken. Continents move very slowly, but over millions of years, the changes are dramatic. The Earth may seem a permanent place, but it is restless and responsive to the forces that surge beneath its surface. The formation of continents, seas, and mountain ranges take millions of years, but the power is awesome. Mountains were forced up for over 40 million years. Geologists believe that some of the peaks were almost as high as Mount Everest. The moisture-laden winds are halted by the peaks. They rise and cool, then rain falls in torrents. Parts of the sea were moved inland. They became rivers, and then where the country flattened, the water spread out to become freshwater lakes. New environments were created, new frontiers to challenge life. When the early fish moved into fresh water, it was probably to escape its predators. But they also had primitive lungs and followed. The early trees, by chance, not only dropped their leaves, more often they dropped entire branches. These would pile up in the shallows and provide an ideal hiding place. To move through such a tangled pile of branches, hands with fingers would be very useful. Possibly this was the reason our ancestor developed limbs. The earliest known footsteps on land are here on the west coast of Ireland. This was once a swamp at the foot of the Caledonian Mountains. These footprints were found in 1992. There were 260 steps made by an animal which put weight on the ground and moved its right and left feet forward alternately, like reptiles walk today. Those first footsteps may have been at night when it was cooler and safer. Once life had conquered the land, nothing seemed to be able to stop it. For almost another 100 million years, life spread across the world. But one dramatic moment in time would see the virtual extinction of all species. What happened was the greatest volcanic eruption to have ever occurred in the long history of the planet. The force of the eruption shot lava as high as 3,000 meters, almost 10,000 feet into the air. Curtains of blazing fire stretched across the horizon. Nothing living in the immediate area could have escaped. When the plants died out, they stopped producing oxygen, and methane gas released from the seabed reacted with oxygen molecules, considerably reducing the atmospheric levels. Some animals managed to survive. One of them was the creature we think is our common ancestor, Cynodont. That it survived at all is probably due to chance and luck. Yet this oxygen-depleted climate allowed a species of reptile to dominate all life on the miracle planet. There are a few fossils immediately above the boundary line drawn in the rocks, but then it changed. Plants had returned, but so had the reptiles. They had grown into giants, the dinosaurs. They spread into every available niche. There were herbivores like these massive Apatosaurus, and terrible predators like the Allosaurus. There were mammals at this time too, our ancestors, but they were of necessity small and secretive, though very recent findings suggest that they did prey on some of the smallest of the dinosaurs. Some 65 million years ago, the mammals were still obliged to live in secrecy, still trying to stay hidden from the giant reptiles which had ruled the world for the previous 150 million years. But that reign was to come abruptly to a close. The dinosaurs were wiped out. Mammals were able to move into every niche, but it was one group that lived in the trees that began a new line in the evolutionary path. This fossil dates to about 9 million years after the dinosaurs had gone. It's called Carpolestes. There is a feature of this skeleton which is intriguing. On one of its limbs there are fingers, and one of them bends toward the palm. This is what primates have today. From this fossil, we can try to reconstruct its world. Like many mammals, it was probably nocturnal. More than likely, it spent most of the time in the trees. It was safer there than on the forest floor. Its diet may have been fruit and berries, but Carpolestes' lifestyle had hardly changed since the time of dinosaurs. There were still ferocious predators on the prowl. This fossil gives the clue. The creature which made this footprint was a contemporary of Carpolestes. They belong to a bird, a giant bird called Diatryma. This reconstruction is based on the evidence gathered from the fossils. There were 4 species of this giant bird. They lived in forests and grasslands, but because of their weight, they were flightless. They could probably run as fast as humans today. But at this time, mammals were still mostly small and weren't able to move swiftly. The ancestor of the modern horse would not have stood a chance. Little wonder that many of the small mammals still kept to the trees. These giant birds ruled from Europe to North America. They were also on other continents in the southern hemisphere. Everywhere except Asia. Here there are no fossil birds, only mammals. The giant birds ruled their domain for another 15 or 20 million years. Their end came as a result of 2 things: a dramatic change in the climate and from conflict. "60 million years ago, there was a long and narrow sea which stretched between Asia and Europe, separating the 2 continents. At the other end, Asia was connected to North America by a land bridge located far north and under permanent ice. Nothing could cross in or out of Asia. So in Asia, mammals began to diversify, safe from the threat of the gigantic birds. And among the mammals was a predator, smaller than the birds, but with distinct advantages. If the oceans were the cradle for early life, then Africa is the cradle for humanity. Climate change has had a huge impact on our evolution. As the continent of Gondwana broke up, India began to move north faster than the other land masses. It collided with the Asian continent, forcing up the mountains of the Himalayas. By 7 million years ago, they had reached around 5,000 meters, 16,000 feet. This was when hominids began to appear in the fossil records of Africa. In summer, a strong upcurrent of dry, warm air rises into the sky over the Himalayas. The dry air blows down to Africa. From being wet and rainy all year, Africa began to have distinct seasons. The Sahara Desert started to encroach on the forests. As the forests vanished still further, grasslands opened up and early humans were faced with extinction. To survive, they were forced to alter their lifestyle. 2 million years ago, there were at least 2 species of hominid living side by side. That evidence was found in the southern tip of the African continent. Fossils from 4 million years ago to recent times are buried in layers. This area has been recognized as a UNESCO World Heritage Site. Sometimes it's called the cradle of humankind. Dr. Francis Thackeray of the Transvaal Museum is an expert on early human evolution.
We have remarkable deposits which are between 1.7 and 1.5 million years old. And in these deposits, we have 2 species. We have Paranthropus robustus, an ape man, and early Homo, living side by side.
Over 7 million years of human evolution, there have been at least 20 different species. Except for one, they have all died out. Moving onto the grasslands was probably forced upon early humans, but they began to gain the upper hand. The brain started to grow. This small brain belonged to an early plant eater. In contrast, this early meat eater grew nearly twice as big, while the extinct plant eater, Robustus, remained small. The human brain consumes more energy than any other part of the body. Perhaps the high protein content of meat helped it to grow. Certainly, early humans needed their brain to help them survive and to live cooperatively.
Meat eating and brain expansion go hand in hand. One supports the other. If some hominin lineages had not begun to eat meat in a more significant way, then we could perhaps use the example of the robust Australopithecines as an explanation for where that might have led. They became extinct by 1 million years ago.
Complex verbal communication allowed Homo sapiens to share thoughts and ideas, to cooperate in the search for food and the struggle for existence. It was a struggle that the Neanderthals would lose, and there would be only one species left on the miracle planet. We became the last survivors.